Hey, hey! So glad to be here, and I'm kind of jealous, man. I wish I could entertain a crowd like Shai can. I usually get excited about what I present, and then I go at 50 miles an hour. So tell me to stop, slow down, so that I don't get too excited. First of all, show of hands, who was here for the presentation that I did online last time? Oh, not that many. So if I repeat a lot of stuff, it's going to be fine. Shai was like, make sure you show them different stuff that you haven't shown them before.
Value.
Value add, yes. OK. So for those of you who have been here before, I apologize if I do the same talk. But for the rest of you guys, we're going to talk about Qwik and cool technologies we make, et cetera, et cetera. So let's just get started, right? Here. I'm going to try to intentionally make it like easygoing talk. So we're going to talk about Qwik. And yeah, that's me. Currently, I'm a CTO at Builder. And I need to explain a little bit what Builder does so that we can kind of see how it all fits in with Qwik, et cetera. So we do this thing called a visual development platform, which is basically this editor you see on the right. And this is how it basically works. You build a website that's on the left, and your marketing department comes to you and says, we actually want the website on the right. And you say, well, no problem, that's easy, right? I'm just going to change this, that, and the other thing, and I'm done. Except the problem is, this doesn't stop. They will keep coming, and it will just never, never end. And so you say, no problem, I know how to do, I'm an engineer. I will put a bunch of data bindings in a few places, and I will data bind to some CMS system, and then they can just do their thing, and they don't have to bother me. Except they still won't stop, because they will come back and says, you know, this week we're having 2 cells instead of 1, and there's no way for us to enter 2 cells in here. We need the color to be red instead of blue. We need this, we need that. And so you will forever be changing these data bindings, and you still won't make them happy. So what you can do is you can install Builder.
But
and then
that's how we make money, Misko.
Well, but as an engineer, you want to work on the value add, the stuff that like the components and things of that sort, right? You really don't want to be changing the homepage. So what you do is you take this thing and you cut it out and you replace it with Builder content. And then this is the important bit. You see on the bottom where it says registered component? These are the components that you as engineers built. And you register with us. And then you paste it into this editor. And then the marketing department can do whatever they want over there. But you build up the components, the individual building blocks, et cetera. And you decide what they want to build and so on and so forth. So as you can imagine, a lot of our customers are e-commerce websites. And a lot of our customers care about speed. And they always come to us and say, hey, how do we make our e-commerce sites even faster? Like it's a constant request. And so the cool thing about this is that we can generate code for any framework. We have this tool called Mitosis. And Mitosis can take this editor's output and generate code for Angular, for Vue, for Svelte, for React, for web components, whatever technology you happen to be using, we know how to generate code for you. And guess what? Doesn't matter which technology you use, your website is probably not going to be so good on Google Core Web Vitals. So the thing we discovered is that existing technologies are basically super heavy on JavaScript. And this is where Qwik comes in, right? So we have all these customers that come to us and they all say, you know, it's just not fast enough. We want the website to be even faster. What do we do? What do we do? And so you go to Core Web Vitals, and the Core Web Vitals tells you what to do. It says on the bottom, at the top, big letters, says, ship less JavaScript, right? And it's true, it's a perfect advice. But I equate it to like saying, I want to be rich, what do I do? And the answer is, make more money, right? Absolutely true, not exactly helpful, because like, what exactly are you supposed to do to ship less JavaScript? You know, like, And so the issue at hand is that we have these wonderful tools that allow us to have great developer experience. Am I speaking too fast, by the way? Should I slow down? OK. But they don't really think about the lazy loading part, or rather how to ship less JavaScript. And so this is where Qwik comes in. Qwik really tries to figure out how to essentially ship as little as possible. You know, the starting point is essentially 0 kilobytes and then go from there. So, and we're going to talk about this when we show you some demos and how to build things, etc. So the goal basically is ship less JavaScript. And the reason for that is because, well, Google cares about it, because Google understands that if you have a slow website, you're unhappy as a customer, and so you want to have, Google wants to make its customers happy, and it wants to funnel traffic to sites that are fast. So Google PageSpeed actually feeds into SEO rank. And if you're a business, you understand that like if it takes forever to click on a buy button, you're going to lose a lot of customers because it takes forever to click on a buy button, right? So there's a lot of money involved in here, and there's lots of studies that basically show like the faster your website is, the better your conversion rates, the more sales, etc. And nobody knows this better than like Amazon. So if you look at Amazon, they're in the yellow, they're not green, but nevertheless, they have basically unlimited resources to make the website as fast as possible, and even they can't get to the green, right? So there's something wrong with the industry, because if you look across, you will see just pretty much everybody's in the red. Everybody, right? No real world e-commerce website that I know of is in the green. Sure, there's like toy websites that people put up and say, look, I'm in the green, right? But like once you add all kinds of stuff to it, it doesn't, it quickly comes down. So Amazon cares a lot, has the best engineers in the world, all the money in the world, and they can only get 67, right? So my argument here is that the problem isn't developers. It's not like you're hiring bad developers that kind of mess things up. The problem is that our tools are kind of against us, not intentionally, but they're not doing us much favors. And the funny thing about the whole setup is that when a website is slow, we automatically blame the developers. We're like, yeah, that company has crappy developers, that's why they're over there. The thing is, if that were true, then you should be able to see some websites that have good developers and have green scores. But such websites are a myth. They just don't exist. So I don't think blaming the developers is actually a fair thing to do. Okay, so why are the websites slow? And the answer is JavaScript. Like over time, the amount of JavaScript is just going up, 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 up. And this is not gonna stop. And people will say like, well, but Amazon, was 15 years ago and you could buy stuff, so why, is it so much bigger now? And the answer is, well, they just do more things now, right? Like, it's not the same website. Like today, for example, when I go to Amazon and I want to go buy windshield wipers, the Amazon actually knows what car I have, and it will only show me the stuff that for my car, which is, I think, is kind of cool, right? Like, but imagine, like, it's not just car, it's about just about anything that you can imagine. They have a special use case for all this stuff. And so these sites are actually getting more powerful. And so to argue that it's the same site, I think, is unfair. So anyways, the problem is the amount of JavaScript is going up, 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 and we need to do something about it. So maybe in the interest of time, I'm going to skip this slide. But these are the top 50 e-commerce websites that we have, that we looked at. And what you can see over there is that the first column is all red, right? There's nobody in the green. There's few of them in the yellow, but for the most part, it's all red. And the thing to notice is that if we take this website, actually, maybe I should talk about this. Sorry. We have this performance insight thing that you can take a website like Priceline, and you can feed it into, and what it does is just sends it to Google PageSpeed and gets a score back. And so Priceline gets a score of 36 out of the box without any changes. And then what we do is we optimize it by optimizing the images, and then we feed it back into Google PageSpeed, and we get the same exact score, which means they already did a good job on optimizing the images. We do the same thing for CSS, same score, meaning already did a good job of optimizing the CSS. And then we delete the JavaScript, and bam, it's an amazing website, right? So clearly JavaScript is the problem. And what this shows that if you look at it as an industry, for the most part, everybody's doing a good job optimizing images, everybody's doing a good job optimizing CSS. JavaScript, not so much. We could get a huge improvement. And this basically shows you that if we could optimize the JavaScript images, we could get everybody up to 83, which would be amazing. Sorry, not images, JavaScript. So what is the problem? Why do we ship so much JavaScript into the browser? And so in one word, the word is hydration. How many people know what hydration is? OK, good, most of you. So I think it's important to understand history of how we got here, right? So originally, we had jQuery. And then there was these single-page applications, Yahoo for jQuery. That was an amazing piece of technology. And then we had this thing called AngularJS. And then the world kind of transitioned from building the applications using jQuery to using component systems, right? And then AngularJS was kind of one of the first. But then, today you have gazillion frameworks to choose from. React, Angular, Vue, React, Svelte, Solid, whatever you want. But they all kind of work fundamentally the same way. And the reason for that is when these frameworks were designed, server-side rendering really wasn't a thing. And so they really aren't designed with server-side rendering in mind. So what happens is you ship HTML to the browser, right? And it's dead. It doesn't do anything. And you want to make it interactive. And so you have to bootstrap it somehow. You have to do something to it to make it interactive. And what really that means is that you have to attach listeners to the right places in the DOM in order to make it interactive. And so how do you do that? Well, in order to figure out where the listeners are, you have to run the render function, because the render function has the information about the listeners. Great. So you have to get to the render function. How do you get the render function? Well, render function is basically a merge between data and a template. So you need to get the data. How do you get the data? Well, you execute the application. And so what you discover very quickly is that in order for you to figure out where the listeners are, you have to download the application, execute the application, and reconcile the DOM of the ones that you executed with the actual HTML that you got from the server. And this bit over here is problematic for two reasons. First is that you eagerly are forced to download the whole application. And the second reason is that you have to actually execute the application. Like if you had to download it but not execute it, the world wouldn't be so bad. But the fact that you have to download it and execute it, that really makes it hurt. And so I'm representing this with a thick arrow saying like, lots of stuff has to come down here. And so Qwik has this idea of resumability. So it's the same exact idea. You start with server-side rendering, but the HTML that you send to the client has information annotated inside of the HTML in the form of attributes where the listeners are. And because it's annotated in there, we have super tiny bootstrap piece of code, which is about 1 kilobyte, and it takes about 1 millisecond to execute, so really nothing. And this allows you to go all the way to the interactive state. You can bypass everything and just go straight to interactive. Right? And now you can interact with your page. And when you interact with a page, the system can lazily download the code. Now, notice this arrow here is thin, this one is fat. Because one of the things the system knows how to do is you take your application and break it up into lots and lots of small chunks. And that's a key bit. So we download the small chunk, and we only download the chunk that's necessary. So if you're on an Amazon website, if you say, add to shopping cart, then we need to download the code, which is the handler for the shopping cart. And we need to probably download the code for updating the shopping cart number, so the template representing the component by the shopping cart, right? So the amount of code that you have to download is way less, right? You don't have to download the menu system. You don't have to download maybe the logout button, the comment sections on the bottom. There's many things that you don't have to download if you can just focus on the actual behavior. And so, yes, the code is being downloaded lazily, but it's so little of it that it actually makes the situation better. Now, before anybody says, like, isn't there a delay when you click? No, because there is prefetching that can happen, and we can get into the prefetching as well. So that's kind of the big difference, right? So we're getting rid of this huge arrow, and this huge arrow here is really where the delay comes from. I'm going to take a little detour. How many people heard of Partytown? Yay. OK, so for the rest of you, here's a quick description of what a Partytown is, and then we're going to jump into some cool demos. So Partytown. So there's two kinds of code that you write, right? You write your first-party code, which is the application that you're writing. And so you start out with your app, and you probably get good scores, and you are very, very happy. And at some point, you say, this is ready for production. And the marketing shows up and says, yes, but you need analytics. You need Facebook Pixel. You need Intercom. You need Amplitude, HubSpot. And they add like 20 scripts. And I'm not exaggerating here. 20 is the average number of scripts that Google reports there are on a page. Okay? So you just download a ridiculous number of third-party scripts. And these third-party scripts will fight for the main thread, right? So not only is your application trying to start up and trying to execute and reconcile and get everything ready so that it's interactive, at the same exact time, the third-party scripts are also waking up and they're doing the same thing. They're like, oh, I'm a Google tag manager. I would like to know about where you click. So let me set up some global listeners all over the place. And also, I want to know what page you happen to be on. So let me read your title, and maybe it reads cookies or who knows what else, right? Whole bunch of things are happening like crazy on the main thread. So what PartyTown does is it says, you know what, let's take the third-party code and move it to the web worker. Because it's a separate thread. All modern devices have multiple CPU cores. Why don't we just move it over there so that we don't have to run it on the main thread, and that frees up the main thread to do more useful things. Now, this is much harder than it sounds. Like, this is kind of like the obvious thing. If you look at it and you go like, of course, just move it to the web worker thread. Like, it's easy. There are some complications. First complication is that in order for Google Tag Manager to be useful, it has to set up listener on your DOM. So if you put it on a web worker, there is no DOM in a web worker, not useful anymore. So what you need to do is you need to recreate the DOM in a web worker. Not just any DOM will do, it has to be the actual DOM that's on the main thread. And so what PartyTown creates is a proxy to all of the APIs that exist on your main thread in the web worker thread, so that Google Tag Manager or whatever tool you happen to have can execute in the web worker thread. Now, there's a tiny little catch, right? So far what I've said, none of this stuff is really kind of earth-shattering. A lot of people had this idea before. The problem is you can't make a synchronous call from the web worker thread to the main thread. And this is where kind of your hopes get shattered, because it's like, Google Tag Manager expects to synchronously read your title. And if you can't deliver it, you'll break the Tag Manager. So how do you do this if you can't make synchronous calls to the web worker? So the cool thing about PartyTown is that we figured out how to make a synchronous call from the web worker to the main thread. And therefore, we can successfully offload Tag Manager or whatever third-party script you have into the web worker, where it can do its magic, and it can do it without affecting the main thread. In other words, we kind of brought multi-threading into JavaScript for third-party code. OK, I'm not going to go much deeper into this other than it exists. You should totally install it, because if you do, you immediately move your third-party code into a separate thread, and your Google PageSpeed score will go up. We have seen as much as 20-point increase just by installing this. So this is like a no-brainer. It works with every framework out there. You should just do this. All right, let's move to demos. And I need both of my hands, so I need my assistant, lovely assistant, Shai. Yeah, hi, how's it going?
Good.
OK, so font, right? How's font? Is it people can see? Is it a good size font? OK, so how many of these demos have you guys seen? Who's seen any of these demos? OK, one person to be so. So I apologize for you who's already seen it. Most of the other ones have not. OK, and so we also need hello world and font here. Font. OK, so here is hello world. Ta-da! Nothing exciting over here, right? The exciting bit is over here. So I have this selected to only show JavaScript. Obviously, if I show everything, there's a bunch of other things that shows up. But it's just JavaScript, right? This is what we care about. And so this static hello world brings no JavaScript. And yeah, that's not that exciting. I mean, it's static, right? But if you think about it, most frameworks can't really differentiate if something is static or not. And so they'll download anyways and try to rehydrate and et cetera, et cetera, et cetera. So in that sense, it's kind of cool, but not really. The other thing I want to show you is that this is how you write a component. For those of you who are familiar with React, you look at this and be like, yeah, this looks exactly like React. There's really very little difference. And that's not a coincidence. One of the things we wanted to do is we wanted to take what's popular and bring in the added value. And the added value is not really the developer experience, but the added value is the things that the framework can do. So really, we want to focus on this magical bit that the other frameworks cannot do. And when I do these presentations, I really want you to be thinking about, like, how would I do this in my other framework? Like, what magical bits would I have to do to kind of get this? So yeah, no special kind of complicated way of expressing a component. So that's about all I want to say for this. And you get a static page and no JavaScript is downloaded. Not that exciting. So let's do something more complicated. Let's do a counter. And a counter has two buttons. One is click, which increases the count. And the second one is hello, that says hello to you. But let me refresh the page again. And actually, let me make this side bigger as well. And look again. No JavaScript, right? No JavaScript here. And when I click on a button, code downloads. And when I click on the other button, more code downloads. How does that work? Like, what kind of a weird wizardry is that? So, you like that, Shai?
Yeah.
Okay.
You can continue.
I can continue. Okay. So, we start with server-side pre-rendering. So we send HTML over, I'm sure you know how that works. But the difference is that in the HTML, you have click listeners, right? So it says on click, and there's a URL which basically says, where do I go and download the code if you click on it? And of course, you need to have a little bit of JavaScript. So here's the quick loader, right? This is the 1 kilobyte thing that executes super quickly. So every page automatically gets it, and we inline it in because it's so small that we don't think it's even worth to make a separate request for it, and so we want to have it inlined. So that's basically this page. And yeah, we have these magical buttons here that do the work. Now, what is interesting about this bit is how you author the component. So let's do a counter. And so we have a counter component. And in here we say that it's a component. I'll explain the $ in a second. And we create a store. So we say, hey, we're going to have a store over here. This looks awfully like MobX. Yeah, it creates a proxy and it listens to things. I don't know who came up with that idea, but like high five to that person.
You could high five in the panel.
Oh, okay. So what this actually does is it creates a proxy. If you want to know more about this, I think there's a person here in the audience who will explain more how this works. And when you read from the proxy, it creates a subscription and everything. Anyways, so the hard part is this, though. This is a single file, single component. How in the world did we end up with 3 separate downloads? So we have 1 and 2. If I click, oh, sorry, I have to click this button here first. And there's 3 files over here, right? So the first file basically said that we extracted just the alert. Nothing else. Look, no framework imports, nothing. We just extracted alert. So when you click on this button right here, what the $ means is that this bit over here needs to be extracted into a separate lazy loaded bit, right? So the system was smart enough to be like, oh yeah, this thing right here, we can extract out into a file. So basically we do something like this, export foo equals this, right? Oops. And this happens automagically. And so you say, well, that kind of is cool and that's exciting and that's kind of neat. But let me show you what happens when I try to do the same exact thing for the second bit.
You have a thing with $signs.
Yeah.
Watch, like money. Are you Jewish?
I don't know, maybe there's some deep down heritage in there. Okay, so notice what I did. When I extracted the code, I broke the code, right? Because the bar, foo was a function that could be extracted. But bar can't be extracted because it's a closure, right? It closes over this variable store that is in its lexical scope. And if you pull it out, you've just broken the program. And so this is where kind of the magic comes in. I'm going to undo this so you can see the magic. I'm going to undo all of this. What we do is, instead of exporting it like so, which breaks it, we have to rearrange the code like this, where we say, restore the lexical scope, give us back the store, and now we can execute it. And this restoring of lexical scope is really the magical bit and the bit why we get to call ourselves resumable. Because as long as we can restore the state of the system, we can just continue where we left off. No need to re-execute anything, right? And so really, behind this use lexical scope lies the framework, right? This is actually imported from the framework. And this use lexical store is the thing that can restore the state of the system and can continue where it left off. And it is, restoring the state is really just JSON.parse. So it's super cheap, and it can be done lazily. And so that's how the system works. So let's look at it again. And notice two funny things here. So the button that just says hello, right? The one that doesn't have lexical scoping, it just says this is the URL, and then this is the symbol where you need to execute. The other button that says click, which actually captured the store, that one has this bracket 0 behind. And this bracket 0 is important because it points to the JSON, which points to the objects, the 0th object right here, which says you need to have an object, a state, which is count 10. So when you go and execute it, and when we execute a piece of code on it that says store.count++, we know that we start at 10, and we're incrementing it to 11, and therefore the application can continue. Okay, so that's the first part of the puzzle. The second part of the puzzle is, well, how does a system supposed to know that it has to re-render something, right? Existing frameworks, I know you can still stay here because I'm going to need it, but like when I talk about stuff, sorry, it feels a little awkward.
It's a Monday.
It's a Monday. Yes, it is a Monday. No, it's a Sunday.
Doesn't matter, continue.
Okay. Where was I? I got derailed. Right, so how do we know to go and download? So let's look at the network tab again. When I refresh this and I hit hello, only the alert code got downloaded and nothing else, right? So if I click on it.
How do you know which part to render?
Right, well, where's this stuff? Why is this thing not showing anything? Anyways, when, oh, because I have to click OK, duh. Okay, thank you. I do know how to use a computer. So here's the alert that shows up over here, right? Now, when I click on a second button, I again get downloaded just the function right here. But then I also download this restore lexical scope that kind of consumes the JSON that I showed you over earlier, and then does the incrementation. The question is, how do we jump from here to here, which downloads the counter so that it can re-render it? And the answer for that is it's all stored inside of our state. And so our state contains our objects. These are listed over here. And it also contains subscriptions. And so in this particular case, what it says is that if you go and modify the count property of the state, then you need to invalidate object 0, or rather component 0. And so component 0 is right here. That's this guy over here. And if you follow the pointers all over the place, you eventually get to this URL over here that basically says, go download this piece of code, and then that's the symbol that's being exported that you have to execute in order to re-render the component. Now, the reason why this is important is that if you don't have this bit and you modify the state, let's say you're in Angular or in React, the problem is that these frameworks are not actually reactive frameworks, and so you don't know which component to re-render, and so you kind of throw your hands up and say, screw it, I'm just going to render everything. And the moment you re-render everything, you just lost, because re-rendering everything means you have to download code for everything, right? And so what we want to be here is extremely surgical about, like, we just want to touch the most necessary things and nothing else, right? So we need to be reactive. So you say, no problem, Svelte's reactive, so can't we just use Svelte? Can't Svelte do this? And the answer is no again, and the reason for that is because in order for a system to be reactive, including MobX falls into this category as well, it has to execute everything at least once to figure out what the subscriptions are. And no different for us. We also have to execute at least once. But we do it on a server, save all that information, and ship to the information in the form of subscriptions to the client. And now the client doesn't have to do that. So Svelte is forced to download everything because it needs to figure out what the relationships are. And once it figures out all the relationships, then it can be super smart about it. But by that point, too late. You already paid the price. You already downloaded everything. So you don't get to have any benefits. Same thing for Angular, React, etc. All the frameworks basically end up in a situation where they have to download everything before they can reason about the system, and it's too late. Okay. So I said you should be thinking about like how would you implement this in your framework of your choice? And the thing I want to kind of point out, oh, the foo is there. The thing I want to point out is that what's hard here is that if you're writing in the existing system, you don't have, like, the framework doesn't care about breaking your application up into pieces. Framework basically says, not my problem, you deal with bundling and you deal with breaking up your application into pieces. And so because it's not the framework's problem, you end up either not doing it, or by the time you want to do it, it's such a convoluted mess that breaking things up is essentially impossible. And then even if you try breaking it up, you'll discover very quickly that it's extremely difficult because the rendering pipelines of all existing frameworks are synchronous, and lazy loading is asynchronous. And you can't take a lazy loaded asynchronous promise and shove it into a synchronous rendering pipeline. That just does not work. And so no matter how you slice it, you discover that like it just doesn't work. Little tangent over here. If I'm doing too long on time, just hit me over the head or something.
I'm here.
Here, okay. A little tangent over here is that when I started this project, I really didn't want to invent anything. I was like, how do I not invent anything? And I looked into React, I looked into lit HTML, I looked into a bunch of different renderers, and I was like, could I just somehow reuse the rendering system and just add the magic around it? In each case, I kind of came up with the answer as being, no, I cannot. Rendering and lazy loading are so tightly coupled that you can't break it up. And what's unique about Qwik is that if you look at existing frameworks, they basically say, what is my job? And the answer is, my job is rendering. And that's kind of tunnel vision that they have. And they don't care about anything else. They just care about rendering, and that's it. And then people are like, yeah, but we need like server-side pre-rendering, and so they cobble together something, and whatever you cobble together something, it's kind of a hack. It's not really meant for this. It's not really working great. It works, but not great. And this is why we have hydration, right? And so the difference with Qwik is that Qwik says, what is my responsibility? And instead of saying it's just rendering, it says, no, 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 no. Rendering is the thing we do as well. Obviously, we have to. But I also care about bundling, creating entry points for the bundlers. I care about server-side rendering. I care about serialization, moving the data from the server to the client. All of the things that you need for having an application, all of them are in the domain of Qwik. Like Qwik says, this is my business. I care about these bits. And because Qwik cares about all these bits, it can do something that other frameworks cannot do. And that bit is basically that we have this tool called Optimizer, which is kind of like a pre-bundler that runs before a rollup runs. And what the bundler can do is it can break up your code and do transformations on it. But normally, bundler also does transformation on a code, but bundler can't semantically change your code. That's not allowed, because then it will break the framework, and bundler and the frameworks don't talk to each other. But in the case of a Qwik, they do talk to each other, and so our bundler can do things that are technically breaking, but it's okay because it understands how the runtime works, and the runtime and the bundler cooperate. And because the runtime and the bundler cooperate, we can do stuff that nobody else can. Right? And not only that nobody else can, I'm going to go on a limb and basically say they won't be able to do it even if they tried. Because if they would try to do it, they would so significantly change the semantics of the framework is that they would create a brand new framework that would be incompatible with all of their existing libraries. So for other frameworks to come in here and say, yeah, we're going to add this as a feature, would mean that they are giving up on all of the documentation, all of the third-party ecosystem that they have, all the learnings that the existing people have, all of that stuff they would have to give up. And I'm going to say, I don't think anybody is going to be ambitious enough to do that. So nobody's going to do that. So I'm going to go on a limb here and say existing frameworks cannot ever do this.
It sounds familiar, the breaking of the old API and the new API.
What are you talking about? I have no idea. That was low, Shy.
No, I'm here. We love you. We love Misko.
Yes, I love breaking shit.
It's not you. You had, you can blame the others.
Okay, so the thing is, if I was to ask you, like, build me a site which doesn't download code until you click on it, you're gonna have a hard time doing it, right? Whereas with Qwik, like, it's just how the framework works, so there's nothing for you to do. Okay, I'm gonna skip the reactivity bit. There is so many cool demos I have, and yeah, he wasn't letting me speak.
Okay. Well.
No? Okay, fine.
You want to show the demo, no?
Yeah. Okay, so here's the demo. Here's the demo. We have a bunch of code, and when you scroll to the bottom, there is a clock, or the 3 clocks actually, I lied. And the cool thing about it is that no JavaScript. And when you scroll them into the view, JavaScript downloads and executes. And it even gets better. So if you look at the DOM, and here's our clocks over here. And if I open the clock, and this is our minute, hour hands, and this is the rotation of the hand, right? And so when I scroll it into the position, it starts updating every 1 second, right? And if I scroll the next one into the position, again, nothing's updating. Second one comes up, and it starts updating. Isn't that cool? Like, how would you do this? How would you do this in the existing frameworks? Like, good luck. And I want to show you how easy it is with Qwik. So we have this clock app. All it does is it just produces a bunch of text so that stuff is below the fold. And here is my 3 clocks that I've inserted over here. And the clock component says, you know, there is some styling you have to load. Here is our store, which is basically the angle of the hands. And this is the magical bit. It says use client effect, which means do some work, but only on the client. And the work basically says, you know, there's an update function that grabs the time, computes the second, minute, hour hand, and then calls the updates and calls it every 1 second. So this is not anything hard. The hard part is not delaying this thing and knowing when to load it. So when you have use client effect on existing systems, what they do is they say, well, that's easy. We'll just run it when the framework wakes up, when it boots up, when it hydrates, right? When we call the hydrate, wake up, or whatever method, that's when this thing wakes up and does its own magic. Except Qwik doesn't really have a, you know, like most systems have like a main entry point where you enter and you do hydration and then a system runs. But if you have a main entry point, then you actually lost because you will, from the main, you go to the root component, from the root component, you go to the children component, from the children component, you go to the sub-children component, right? And so you download everything. And so instead, we just have to resume where we left off. And so the question becomes, well, when do we resume this particular component? And so that you can pass an extra argument here, but the default argument says, resume the component when it becomes visible. And so by default, you get this beautiful behavior where nothing happens, you scroll into the view, and you wake up the component and it starts executing. Now, we don't have this implemented yet, but I really want to implement the fact that when I scroll out of the view, it should just shut it down. And then you have the best of all the worlds where you can do this. OK, so what is QwikCity? This thing right here is built using QwikCity. So this is our homepage. And QwikCity is like the Angular Universal or the Next.js, or Vue has SvelteKit, right? Sorry, Vue has Nuxt, right? Nuxt. And again, this was a situation where like we looked really hard at Next.js. We looked really hard on what is the super popular one on? Remix. We looked at all of them and we said, could we just reuse them somehow? Because we really didn't want to rebuild QwikCity. And unfortunately, the answer is no, because they're so fundamentally different. Like the way you think about it, the way you deal with it, the way you deliver JavaScript, everything is just so different. It just doesn't fit into the mental model of the existing systems. So what I like about this QwikCity is that we have, you know, file-based routing, exactly as you would imagine. We have all the bits, but one of the things that we can do is we want to make sure that if you click on this, it's instant on, right? So if you look at the network tab, we still have to download the code, except that if you refresh, okay, click. Wait, why is it broken? Oh, is it because this? Okay, here we go. So because the disabled cache was on, off, that's why it got broken. So what we do is we set up prefetching. And notice when you actually go and fetch the code, it's hard to see, but it actually says prefetch cache, right? And you can see that it says prefetch over here on the beginning. And the reason that works is because when we go to the bottom, we generate links. So the way this works is that when we run the application on a server, we look at all the components and we learn a lot about your application because we actually run the application. It's not a static analysis, it's runtime analysis. We can look at it and we can see which components have data, which components have subscriptions, which subscriptions are subscribed to what. We can see which listeners exist in the system, and we can see if a listener has a reference to a store. And this graph allows us to basically tree shake, but not the code, but the data. And we can throw away a whole bunch of stuff that we know, like, technically this is data that at one point was needed to render the application. But looking at the application in the client, we actually can tell that none of this stuff is required, and we can all be thrown away. And so after we throw away all the data, we end up with a set of routes that are required to be shipped to the client, and this set of routes produces these URLs that are prefetchable. What these prefetchable URLs basically do is tell the system, like, hey, you need to go this, this, and that. And because these URLs get prefetched, your interaction becomes instant, right? If you click on a button, it's an instant interaction. There's really nothing for the system to execute. But we also were able to look at the page and throw away a lot of stuff. So if your use case is a use case that falls into the category of Remix, Nuxt, etc., all these frameworks, then we have QwikCity. And QwikCity is this file-based routing. Microphone holder, thank you. So the way you do this is you say npm create quick.
Create.
What did I do? Oh, create.
Pair programming.
Quick. Okay. And you will say, what do you want to do? You want to say quick Israel? That doesn't look right.
No, Israel. Yeah.
And you select QwikCity, Express, prettier sure, and we can do code dot. And we can, oh yeah, in here, we can then do control.
You're in the home page. You need to go inside the folder you created.
Oh, oops, thank you, thank you. Thank you, thank you, thank
Don't
you.
share your Visa number.
Quick dash. npm install.
Yeah, you're sure you want to do npm install now?
Well,
We need to show it. Yeah.
yeah.
So anybody got a cool story while we're installing?
Bad joke. How do functions break up? They stop calling each other.
All day like this, all day.
You don't like my joke, man?
I like your joke. What? My face is like, this is my like face.
All right, so we should be able to go to oops, that's not what I wanted here. There you go. And so this is kind of a basic skeleton of QwikCity. And here you can come and add pages, etc. And you get the same cool.
This is like brand new, right?
This is brand new. This just got released. It is so new that we're going to have another release soon. Right now we only support, unfortunately, MDX format, but TSX is coming like any day now. We already have it working. We just have to land the PR. The cool thing is you have your documentation. Let's say there's an increment component in the middle. So let's again do our, this is not responsive, huh? Network tab. And by this point, you're not impressed anymore that there is no JavaScript downloaded, right? And there is a component here. If I click, of course, the counter gets downloaded and executed, and it updates the count. This is it. Control J. And how does this work? So we have, you set up your layouts, and you have your pages. Inside of the index, you kind of do what the menu system on the left. And for example, if you go to index MDX, you can write your code, you can import your component. In this case, it's a counter, and you can drop it inside of your code base in here. And of course, everything is set up with prefetching and all the pieces so that this page should continue to have 0 JavaScript, and then no matter how complicated your website gets, et cetera, et cetera, et cetera.
So how do you add like a route?
So in this case, this is a file-based routing, so we could add, let's add route.
You have already a route, each page is a route?
Each page is a route.
MDX?
MDX.
MDEX.
It's like MD, but like with...
MDEX.
Oh, MedX.
MedX.
I was just checking if you're paying attention.
Yeah. Pair programming. Together with Misko.
Okay, so now if we go to, oops. Shy. Ta-da! Wait,
Yeah,
what?
not found, but I'm here. Misko, I'm here. You know?
There goes live demos, man, that I'm not ready for.
The demo gods. I thought about like a cool podcast.
Hey, here we go.
Demo god. Hey!
Here we go. So the text is here, and of course it's inside of a layout, right? So we have the footer over here, we have the menus on the left, and so on. And we can also put components in there like I showed you earlier, so we can put all kinds of stuff. Anyways, right now it's just MDX, but it will be a TSX demo, etc. Did I fill my time? Did I go over?
So. Yeah.
All right.
Closing words or what?
I'm just gonna say, like, I wish I could have showed you the hacker news demo. There's a pretty hacker news demo we have here, and of course, every app has to have a to-do. So I know I showed you extremely simple examples, but we can build super complicated stuff. And the thing that we're most proud of is actually this bit right here. We have a whole tutorial which is actually running in Qwik. Obviously, the whole page is written in Qwik. And guess what? This page, normally when you have these tutorials, they're like a standalone app that doesn't SEO work, right? But like this works beautifully with SEO because everything gets server-side pre-rendered, and so we automatically get SEO content. And this thing has a lot of complicated things involved in here, including, what is the code editor from Microsoft called?
VS Code?
Yeah, VS Code, Monaco. Monaco is integrated, etc. So just trying to point out that this is not like a toy stuff that we can build. We can build some super complicated things. With that, I will hand it over to the MC.
Yeah. Good job, buddy.
Thank you.
Misko Hevery.